So hi all, welcome back. In this video, I will be showing you the solution for the furniture problem. The furniture problem that we formulated as a linear program. Quickly, the linear program looks like this. This is the objective function. These are the constraints, and we're going to formulate this problem in Excel and solve it. Okay. So the first step is entering the data in Excel. Now, I'm going to use a certain way of solving these problems. This is especially useful for all types of linear programming problems. Now, there are some special type of linear programming problems, especially to do with supply chains, that we'll be looking at next week. Those you formulate them slightly differently, but the ideas are very similar. But this is a standard way of setting up linear programming problems. Now, the objective function and constraints will be set up as rows, while the variables will be set up as columns. So we have two variables. We have chairs and tables. So we have a T and C as a variable. Then I'm going to have another column called the formula, and then I'm going to have another column called the constraint. Right. Now you'll see what these are in a second. So the first step is to first enter the data. Now this is where the first two, I'm going to say that the final value of the decision variables are going to show up here. So these two cells that I'm going to color, like coloring cells. So these two cells are going to be the final value of the decision variables, and as we set up our problem, these two cells are going to be the cells that are going to double for T and C in all the formulas. So whenever we have a formula that says T and that says C, we are going to refer to this cell and this cell respectively. Right? That's the decision variable. So let's write the objective function. Now remember, right now we're just entering the data. So the objective is 7 times T plus 5 times C. So let's enter the coefficient 7 and 5 here. 7 times T plus 5 times C. So this is the objective is a function. So there is no right hand side, or there's no constraint there. But let's write the two constraints. You have the carpentry constraint and the painting constraint. So carpentry constraint is that you have 2 times T plus 3 times C is less than or equal to 2400. Right? 2 times T plus 3 times C is less than or equal to 2400. It's the carpentry constraint. The painting constraint is 4 times T plus 1 times C is less than or equal to 1000. That's the painting constraint. So you have a carpentry constraint and the painting constraint. So right now we've entered the coefficients. Now we have to tell Excel that the formula for the objective function is in fact 7 times T plus 5 times C. We can't just know Excel to expect Excel to know that by itself. We have to input the formula explicitly. So the formula should essentially say 7 times T. So that will be B4 times B2 plus C4 times C2. Now, because this is a small problem, you can write each formula out individually. But what I'm going to do is I'm going to show you a standard way of writing this formula, which makes it much easier even when you have a large number of variables and large number of constraints, as you will see in the next two examples, that next two videos that I've posted. Okay. So the standard way of doing that is we use the function in Excel called the sum product function. The sum product function, as the name suggests, is a sum of products. By product you mean multiplication. Multiplying two numbers together, it's a product of two numbers. So this finds a sum of products. So the formula of all the objective function and all the constraints, the left hand side of the objective function and the constraints are essentially a coefficient times the variable plus coefficient times the variable. So multiplying two numbers together, and adding them. That's why we use the sum product formula. So when we use the sum product formula, now for the objective function and the constraints, we are always going to refer to decision variables which are in the same place, but the coefficients change. The objective function coefficients are here, the Carpentry constraint coefficients are here, and the painting coefficients are here. So we write the sum product function this way to take advantage or to keep track of that fact. So the objective coefficient functions, comma, the decision variables. Now, because all formulas contain the decision variables which are in the same place, I am going to make this an absolute reference. Now, the dollar signs means it's an absolute reference. I hope all of you know what an absolute reference is. In case you don't, my suggestion is you can look this up. It's a very common tactic used in Excel formulas about having absolute and relative references. So, what does this formula say? So this formula says that I want to take these two numbers and these two numbers, multiply the corresponding numbers together, and then add them up. Find the product, and then sum the two products, as the name suggests. Now, you will see the reason why I have dollar signs here and no dollar signs here. Once I have this formula, if I can just copy it down, I'm just going to get rid of this. There's nothing here. Now, if you look at this formula, notice that because I didn't put dollar signs for these two coefficients, the coefficients have changed to the corresponding row, but the decision variables have remained the decision variables right here. So that way, it makes it easy to write my constraints. Now, in larger problems, you'll have constraints, some constraints that are less than or equal to, some constraints that are greater than or equal to, some constraints that are equal to. My suggestion is that you write all the less than or equal to constraints together, all the greater than or equal to constraints together, and all the equal to constraints together, so that when you input them into Excel, when you solve them in Excel, it'll be easier. You'll notice. So this is step one. Once you have input the data and the formulas, the next step is to put this into the solver. Now, go to your data tab and find solver. Now, if you're not able to find solver in your data tab, then you have to enable the add-in. So solver is an add-in and you have to enable it separately. Go look up a YouTube video. It's a very straightforward thing to enable the solver, but because I have a Mac and I know that many of you have Windows, you might not know how to, I won't be able to show you how to enable it on a Windows computer. But on a Mac computer, it is simple. You go to Tools, you go to Excel Add-ins, and you'll notice the Solver add-in. Make sure that it is checked, and then click OK. And Solver will show up here. Right. For Windows computers, please, I will see if I can post a YouTube video, a link to a YouTube video. If not, just look up a YouTube video. It's a very straightforward process. Okay. Solver. So once I click on Solver, the solver is built specially for mathematical programming problems. So as we know, there is an objective. So we have a place for an objective function, we have place for variables, and we have place for constraints. So let's use them. Now the objective, this is where you use the objective function. Let me start this just for a second. All right. So the objective is this cell. So remember, you cannot use 7 and 5. 7 and 5 just the coefficients. This is where we've written the formula for the objective function. So this is the cell that you have to choose for the objective function. That's the formula for the objective function. It's D4. Let's say D4. Don't worry, the sheet one, that's just the name of the sheet. I don't know why it shows up, but it shows up here. That's okay. So D4, this is where the formula for the objective is, and that's our objective. And in this case, the objective is to maximize profits. So I've chosen max. Now, in some cases, it might be to minimize costs. So in those cases, make sure that you click on min. Okay. Next, the next step is to set up the decision variables. So in our case, there are two decision variables right here, T and C. So I'm going to choose the two decision variables. So those are my two decision variables, B2 and C2, and input there. The next step now is to add the constraints. So let's add the constraint. Now, both my constraints are less than or equal to constraints, so I'm going to add them all at once. So I'm going to say that the left-hand side of both of these constraints, so D, D6 and D7 is less than or equal to, so you leave the less than or equal to the right-hand side of the constraint, which is 24 and 1000. So because I've chosen both the left-hand sides and both the right-hand sides, I can write just one constraint. I don't have to write multiple constraints. There you go. So I have the objective, maximize the value of the objective, my decision variables, my constraints. Now the other thing that I have to do is to change the, so make sure that you have this box checked. Don't uncheck this box. So remember, I said one of the technical constraints is that all variables are non-negative. We have to make sure that all variables are in fact non-negative. Now the other thing that you have to make sure is to change our solution method. So we don't have non-linear programming problem. We in fact have a linear programming problem. So change it from non-linear, GRG non-linear to simplex LP. LP stands for linear program, right? So change it to simplex LP, and then we click on solve. Solver found a solution. And there you have it. So according to this solution, you should be making 60 tables and 760 chairs. You will be making a profit of 4,220. Now to do this, you will be using up all the, so you'll notice that the left hand side is 2400 and the right hand side is 2400, which means that you'll be using up all the carpentry time and all the painting time, right? And that's what the final solution looks like. So the final solution has two parts to it. One is the number of tables and the number of chairs that you are going to manufacture. That's one part of the decision. The other is how much money you're going to make. So based on these values, you'll make a profit of 4,220. And the fundamental theorem of linear programming tells us that this is the maximum profit you can make. You cannot make any more than 4,220. That's the maximum profit. So this is how you solve a linear programming problem, and I will be posting a couple, like I said, 4 more videos. So formulation and solution of 2 more problems, an example from finance, another example from marketing, right? If you have any questions, so I'll be solving another problem in the synchronous session. If you have any questions, you can either email me or come to the synchronous session and ask me that. Right? Take care.